In our previous video, we talked about how and why ions are formed. In this video, we will learn about how ionic bonds are formed to make compounds. To refresh your memory, ions are formed when atoms lose or gain electrons. The number of electrons lost or gained is determined by the fact that atoms are trying to attain a stable configuration like the noble gases. As you might recall, the noble gases are located all the way on the right side of the periodic table, right over there. The electrons involved in these changes are the valence electrons, which you should recall are the outermost electrons in the atom. Hopefully you remember that the number of valence electrons that an atom has is determined by its group number. Such as group number 1, all these elements have 1 valence electron. All the elements in group 2 have 2 valence electrons, group 3 have 3, and then it goes all the way across to group 8, and so on. One of the things we haven't talked about is where do the electrons go that are lost by these atoms, and where do the electrons come from that are gained by these atoms? The short answer to this is that atoms which need electrons tend to hang around with atoms that want to lose electrons, and as a result they form what is called an ionic bond. Metals tend to lose electrons to form cations. Hopefully you recall that the metals are to the left side of the stair-step line, so they're right over there. Nonmetals tend to gain electrons to form anions, and they, as you might recall, are located in this region of the periodic table to the right of the stair-step line. So, as a result, ionic bonds are usually formed between metals and nonmetals. The following worksheet will help to provide you with a visual to represent the steps in ionic bonding. Let's look at the worksheet now. I want to direct your attention to the example problem at the top of the page. Step 1 is to look at the equation to identify the atoms involved. The equation is right here. So in this equation, we can see that lithium reacts with fluorine to form the compound lithium fluoride. Step 2 is to draw the atoms showing the electrons in their different energy levels. To make this drawing, we need to look at the electron configuration. The electron configuration for lithium is 1s1, 2s1. Excuse me. It's 1s2, 2s1. So in our drawing, we can see that there are 2 electrons in the first energy level. That's these 2. And there is 1 electron in the second energy level. That's this one right here. Let's look at fluorine now. Fluorine has an electron configuration of 1s2, 2s2, 2p5. So now looking at the drawing, we can see that there's 2 electrons in the first energy level, that's these 2, and there's 7 electrons in the second energy level. That's all of these guys here. Step 3 is to identify the valence electrons. The valence electrons are the outermost electrons of the shell, and they will be the electrons that are actually involved in the bonding. So the valence electron for lithium is right here. And so it has 1 valence electron. Fluorine has 7 valence electrons. So all of these electrons are in the outermost energy level, so we'll write 7 here. Step 4 is to decide if each atom will gain or lose electrons. Remember, atoms gain or lose electrons to look like noble gases, as they will always choose the easiest path. When we look at lithium, which is right over here in the periodic table, the closest noble gas to lithium is helium. If lithium loses 1 electron, then it will look like helium. And I just want to clarify, it doesn't become helium. It's still lithium. In terms of its electrons, it just looks like helium. On the other hand, with fluorine, which is right over here, all it has to do is gain 1 electron, and it will look like neon. So going back to our worksheet, lithium will lose 1 electron, and fluorine will gain 1 electron. Now looking at our diagram, it's represented by this right here. So 1 electron is lost from lithium, that electron is then gained by fluorine. And so they work really well together. The last step in this process for the worksheet is to identify the ions formed. In this case, because lithium loses 1 electron, it will become lithium plus 1. And because fluorine gains 1 electron, it will become fluorine minus 1. Well, now it's your turn. When you get to class, you're going to work some examples.